We're going to be looking at question number 9 from the 2014 Revised Higher Physics paper. Quite often this is one of those questions where pupils don't really know which way to go and they just guess one or the other, but I'm going to try and teach you tonight how to solve the problem. Hopefully you'll find this useful and you'll remember it as a way to do it. The problem is, of course, that every teacher teaches it differently, so I'm going to tell you my way and you can take it or leave it. So what have we got? We've got an electron entering a region of a magnetic field as shown. Now, this is the electron and it's a negative charge and it enters here, and this is a region of magnetic field, and the x's represent that the field is traveling into the page. And the question says, the direction of the force exerted by the magnetic field on the electron as it enters is to the left, into the page, out of the page, toward the top or the bottom. Now, the only two possible answers really that are in any way remotely correct are either D or E. The electron cannot experience a force parallel to its motion, and it cannot experience a force parallel to the magnetic fields. Magnetic fields are traveling into the page, so it can't experience a force into or out of the page. That would be parallel or anti-parallel, and it can't experience a force to the left because that's in the direction of travel of the electron. So it's either upward or downward. And so to solve this problem, I'm going to do something which I rarely do, which is show my face. And the reason for that is because I want to show my hand. My hand is just as interesting as my face often. So let's go through this. I use the left hand rule for this type of problems, and I always use it because I remember the left hand is for positive charges. And yes, you'll say this is an electron, but we'll deal with that later. So when I do this problem, my first finger is the field, my second finger is the current, and my thumb shows the direction of the force. Now, second finger current, in this case it's a charge, first finger field. So the field is pointing into the page, so I'm going to put my finger forward into the page. The second finger, the current, is traveling to the right in terms of the diagram, and then as you can see, my thumb, which is here, is pointing upwards, and that would be the direction of the force on a positive charge. But haha, this is not a positive charge, this is an electron, and so therefore the electron will experience a force downward and not upwards. So downward force means it will curve downward toward the bottom of the page, and so our answer is E. Okay, I hope you find that useful, and that's probably the last you'll see of my face for a while. Bye bye then.